We're in Advanced Math Trig, mods 2, 3, 4, and 7. Our next to last day of notes together. The last specific review function from our library of functions before we do something called piecewise functions tomorrow on Thursday is a look at a quick review of the trigonometric functions, which were really, I think, the first functions I was touching base on and teaching with you when I took over for Mr. DeMarco. So today in your notebook, 5/20/20, so this is Wednesday the 20th, trigonometric functions is the title. Quick note, it's up to you whether you want to jot the quick sketch down to remind you, but it's on your library if you've got your library out, your library of functions out to refer to. The sine graph, remember, started right on the origin, took on this roller coaster shape, ended way down on 2 pi. So its amplitude, its height was 1, right? And its period was 2 pi. That's how long it took to complete the entire cycle. And the 4 marks we always put were pi over 2, pi, 3 pi over 2, and 2 pi. That's the nice normal y equals sine of x function. The cosine, instead of starting on the origin, did start at its max of 1. Halfway through that roller coaster ride at pi, we reached the minimum of -1. Passed back through the x-axis at 3 pi over 2 and eventually hit the max again at 1 down here on 2 pi. So his amplitude was also 1 and his cycle, his period, was also 2 pi. With those as the normal 2 functions that we've got ingrained in our brain or sketched here on our paper, just a quick review of what other numbers thrown into the standard picture would look like. Remember, the number that's in front of the word sine or cosine affects the amplitude or the height of your picture, and any number next to the letter x is going to affect the period and how long this picture is going to be. So real quick, just as a note off to the side here, let's put A for amplitude. The amplitude is the number in front, which of course is 2. That's the maximum height or the actual low we will eventually hit. The period, again, meaning how long this curve is I'm about to draw, normally is 2 pi, agreed? But remember the rule was what? I'll let you think for a second. Wasn't it divide by the number that was out in front of that x, which in this case is 2. So if those 2's cancel, this graph I'm about to draw only has a period of pi. It's only half as long as normal. Now, the other thing we always listed was horizontal shift, right? There is no shifting horizontally going on. That only occurs, remember, if you look at our next problem, when there's a number tacked onto the x inside of our parentheses. So in this case, there's no horizontal shifting, which makes it pretty quick and easy to sketch. So all I need to see on your sketches for homework, I would say give me the amplitude, give me the period, give me the horizontal shift, and then draw a picture. If you remember back to when we did these, the whole goal is to see what this curve looks like compared to the normal one. So if your period is 2 pi or less and has not been expanded, go ahead and put 4 nice, neat, equally spaced marks. Call them pi over 2 pi, 3 pi over 2, and 2 pi. So even though we might not need to go all the way down to 2 pi, that allows us to see this picture compared to the normal cosine graph, okay? Obviously, if our amplitude here is 2, I'm going to go up 2, label them 1 and 2, down 2, label them -1, -2, and I'm going to draw my cosine graph. And if you think back to when I taught this, I said it was critical to have what? Remember, a starting dot, an ending dot, and a middle dot. Since this is a cosine graph, our first starting dot is normally at 0 degrees up on 1. So I'm going to go to 0 degrees because there's no horizontal shift. And since the amplitude is 2, I'm going to go up and put that starting dot on 2. And I'm picturing the same shape that the normal cosine graph takes, but my last dot, which of course will also be up on 2, is going to be found where? On pi, because that's how long this roller coaster is. So everybody go to pi, go up to, oh my gosh, I've already got my starting dot, I've got my ending dot. So of course the middle dot is pi over 2. And remember, on the cosine graph, that middle dot will show us where our minimum is at right here. So somewhere in between, we're going to cross the x-axis there, and in between here, we're going to cross the x-axis. Hey, neatness counts. This is not a V. This is a curved picture. Whoa, so it's a cosine roller coaster that's twice as tall as normal, but the length of the roller coaster has been shrunk in half, and my picture looks like that. Okay? So notice I could say, what's the slope of that curve right there at that spot? And slope is found by taking the derivative of a function. So yes, you will have to know how to find derivatives of trigonometric functions to find the slope. I could even say, what's the area between that function and the x-axis from 0 to pi over 2, in which case we could color in some area here and then color some area down there. We'd have some positive area, some negative area, so I wonder what the total would be. So you could integrate this trig function in calculus next year and try to plug in your boundaries and calculate areas in different sections of that picture. Obviously, that's not going to work if you can't make a sketch of the normal cosine graph that we just created, okay? Now, a lot of times, again, the trigonometric graphs, if they do get any fancier than what I'm sketching here, you will use that as, on the calculator part of the test. But if it's a fairly basic one like this, you're expected to know how to sketch it, okay? All right, real quick, number 2 here says negative sine of x minus pi over 2. If this is you doing your problems or your assignment tonight, give me A for amplitude, P for period, HS for horizontal shift. The amplitude is always the number out in front, which in this case is -1. Go ahead and include the negative sign. That simply means it'll start down instead of up, right? If it's a negative. The period, now good news, is normally 2 pi, and you're supposed to divide by the number that's out in front of the x or in front of this parenthesis, but there isn't a number there. So the period will stay 2 pi like normal. That hasn't been changed. The horizontal shift, if you remember the rule, is the opposite of the number that's in there. So the opposite of minus pi over 2, pi over 2. Should be all coming back to you. This is the last time you're going to get taught this. You got to know it moving forward. You're expected to. So real quick, if I put the big 4 marks, call them pi over 2, pi, 3 pi over 2, and 2 pi. I'm just going to go up 1 and down 1. Okay, now careful. This is a sine graph, isn't it? You got to keep the general shape of a normal sine graph, which starts normally on the origin. Okay? Just because my amplitude's -1 doesn't mean I start down on -1. There's no vertical shifting going on. That just means that you're going to reach your min before your max when you draw the sine curve. So do you agree that a normal sine graph starts on the origin? This sine graph will start on the origin. Boom. But wait a minute. There was a horizontal shift of pi over 2. So instead of putting the dot right on the origin, I'm going to go over pi over 2. And that's where my first dot will be located. Agreed? Because there was a shift horizontally of pi over 2. Now, if this period is 2 pi long, and this snake or this roller coaster would have ended on 2 pi if we would have started on the origin, doesn't that mean that the ending dot gets shifted over pi? So you put another mark, and we're moving another pi over 2 to the right for the ending dot, which would be 5 pi over 2. And there it is. So, of course, the dot right in the middle is 3 pi over 2. Everybody good? Halfway in between, normally we would go up and put a dot on 1 because we would reach our max at that point. But because my amplitude is -1, I'm going to go down and put my minimum. And then in between these two, we'll reach our maximum of 1. So notice my amplitude of -1 was achieved. The length of 2 pi has been achieved, but everything got shifted horizontally because of the -pi/2. So connecting those up, looks like that. Bam, and we've got our picture sketched, okay? Just calmly think your way through it. You're allowed to use your high IQs. And finally, oh boy, let's challenge ourselves here. I've got a cosine graph. Again, this is you doing your assignment. Might as well just do AP and HS, right? Amplitude, period, horizontal shift. Now, there is no number in front other than what's understood to be a 1, so the amplitude's 1. The period is 2 pi. Now, I'm supposed to divide by the number that's in front of that parenthesis, so I'm dividing by 1/2. Remember, when you divide by a fraction, you really multiply by the reciprocal. So dividing by 1/2 is multiplying by 2. So, oh my goodness, this roller coaster has a period of 4 pi. So immediately I'm thinking, when I go to sketch this and I have my 4 marks to the right, I'm going to go pi, 2 pi, 3 pi, and 4 pi because I know the period or length of this snake has been extended. Okay? I'm going to go up 1 and down 1. Is there a horizontal shift? Yes. What's the opposite of +pi/2? -pi/2. Oh, now careful. Okay, look at my pen right now. That mark to the right was pi, wasn't it? So this mark I'm going to put here is -pi. If my first dot normally on a cosine graph is at 0 degrees up on 1, I've actually got a horizontal shift of -pi/2, which would be right there, agreed? And I would put my dot up on 1 and start right there. Okay, now let's think logically. If I would have started at 0 degrees, we knew this roller coaster was how long? It was 4 pi, wasn't it? So I would have ended way down on 4 pi. But again, there's a horizontal shift of -pi/2. So I go left pi/2, which is right there. And that'll be my last dot. So my middle dot would have been 2 pi if there wasn't a horizontal shift, but there is a horizontal shift of left pi/2, and that's where I'll achieve my minimum of -1. Okay? So with that in mind, I can now come through and make a nice looking curved shape that looks like a cosine graph. And it looks like that. Okay? That's review of cosine and sine. I took my time and went fairly slow to, again, recall what we're thinking as we do each step. The goal is quickly and accurately sketch it so that you can then answer the calculus questions. Okay? Now, good question for you. Look at this one right here. What if I would have said, what's the slope of that function at x equals pi? Oh, when I go over to pi, wouldn't that be this dot here? Isn't that dot a vertex or a turning point? And remember, to calculate the slope or estimate it, you draw a tangent line through that point, which would be horizontal. So we know the slope would be 0, and we could answer the question without taking the derivative of that function, all because we were able to sketch the picture pretty quickly. So again, just kind of proves it into the near future here. I know this has been a rough spell, but guys, you'll be sitting in calculus hopefully before you know it for your senior year doing stuff like this again. All right? All right. Your 3 homework problems or your assignment for this section. Again, today is what? Wednesday the 20th. So this lesson, this 3 problem assignment is due tomorrow, Thursday the 21st. Tomorrow, Thursday the 21st, is our last note-taking session together. We'll cover a topic called piecewise functions. You'll see what that is when I explain it. And then we end things on Friday with just a general wrap-up day to figure out and finish up those grades, okay? You're doing a great job. Hang in there for 2 more days. These are your 3 homework problems for your assignment. Go ahead and hit pause and copy those down. Give it a shot. Turn those in by noon tomorrow, okay? I'll see you then. Great job.